Good morning to all. My research topic is a offset framework for multi-human tracking in surveillance video. In the recent years, multi-human tracking has a key focus area in surveillance applications since it is a base work for doing multiple human-based research such as human recognition, human behavior analysis, abnormal event detections, and so on. However, human tracking is still a challenging problem due to human spatial disorder, occlusions, nonlinearity. Also, most of the classification algorithms do not consider the positional coordinates while tracking the humans in the consecutive frames. To overcome above all challenges, this work proposed the rough set theory, or to make the rough set theory is used to make the rough set framework by using modified bounding box classification and rough set framework and displacement measures. From the literature review, I have found some research gap. Here I have mentioned here. If two or more people connected with together, that is overlapping. Overlapping is not efficiently addressed by the existing research methodologies due to not considering positional coordinates of humans in consecutive frames. Then labeling is a difficult process due to missing information of hidden and exit humans, and thus leads to humans over labeling and humans duplicate labeling. If the humans are from the camera or occluded by another one human, then the algorithm does not get the information for that particular humans. So finally, several existing similarity measures fail to reflect the realities, where if there is no common positional features between two humans, there would be giving the smaller distance than the other identical pair of humans. To develop the proposed methodology, there are three techniques I have developed. First one, modified bounding box generation technique. Then one, it is used to split the humans if two or more humans connected together. Then novel rough set framework, it is used to find the non humans with non-linearity. Then the displacement measures is used to find the human whether occluded or exit from the camera. This is the overflow of this is the workflow of rough set framework. This is a proposed methodology takes the input as the surveillance video as the input for this algorithm. Then background elimination is needed for extracting the foreground. Then modified bounding box generation is used to split the humans if two or more people connected together. Then feature extraction is needed to if the people is in the next frame or not. Then the rough set classification is used to classify the humans for labeling. The proposed methods applies the background model to subtract the foreground from the background. Then connected component analysis is used to find the connected pixel values from the foreground regions. Then finally, this is the human-based analysis. So we have to find the moving object from the foreground regions. Optical flow computation is used to estimate the moving pixels. It is used to remove the static object in the subsequent process. To enhance the person identification process, modified bounding box generation techniques is used to split the humans if two or more humans connected together. So first it predefines the standard humans. This values the standard humans height and width. I have taken by using multiple text frames. That values taken from multiple camera views. Second one, measure the size of overlapped humans. This is analyzed in the four cases. First one, it is a single human. It is present in the connected values. Then overlapped in horizontal direction. Next, overlapped in vertical directions. Fourth one, overlapped in horizontal and vertical direction. If the person is overlapped in the horizontal and the vertical direction, the algorithm considers the positional coordinates in the consecutive frames also. So then the corresponding humans values divided by the standard humans values. Finally, the connected overlapped humans splits according to the ratio. This is the example of a bounding box with all cases. We can see this is it consists of single humans and overlapped humans in the horizontal direction, vertical directions, and for both directions. Statistical features extractions techniques is applied on the bounding boxes. It is used to extract the features for ensuring humans in the consecutive frames. Here I have applied beta distribution. It is used to find the shape of the variables, the values from 0 to 1. Rough sets classification is used to classify the humans for labeling. Let's see and see as be the current and previous frame. First, we have to form the universal set that consists of human object in the consecutive frames. Next, to form the feature set of humans in the consecutive frames of the humans. Next, again form the subset of positional features between two humans. Finally, analyze the similar positional features attribute values between two humans by using the indiscriminate relations. Here I have given the formula. Then estimate the equivalence relations on the universal set, which consists of humans in the consecutive frame. Then compute the lower and upper approximations of using the feature attributes. Based on this lower and upper approximations, the algorithm find the boundary regions. The boundary regions is called the rough set. Rough set is a formal approximation of a crisp set using equivalence class. The values from lower and upper approximations with respect to the indiscriminate relations. Then finally, the algorithm calculates the membership for the humans. If the humans will get the highest membership, that humans classify the humans as the identical humans for the labeling as the previous frame. Displacement measures is used to find the humans whether occluded or exceed. If the algorithm does not get any values for the humans in the current frame, the algorithm check the positional coordinates in the previous frame. That is called location features. So if the distance between the two consecutive humans will be less, the algorithm decides the human occluded is hidden by another human. Otherwise, if the algorithm gets the highest values than the threshold, the algorithm decides the humans out from the camera. So I have used pedestrian 2009 data set for the experimental result. So to evaluate the effectiveness of the proposed methodology, I have used 3 algorithms for comparing. So from the experimental result, the proposed methods give the better accuracy. So this is the experimental results. The framework addressed the all issues such as overlapping occlusions and nonlinear motions. So from the literature review, we have found the rough set framework outperforms than the other existing algorithm. The proposed method performed well while tracking the human wide range of humans' motions. Then in the future, this framework easily extend to abnormal event detections, human behavior analysis, and scene understanding. These are the reference needed for developing the proposed methodology. Thank you.